In this video, we're going to take a look at a method for solving a system of equations called the substitution method. And if you think about this word substitution, this really means taking something and replacing it with something that is equal to it. And we're going to use that idea in 3 examples here, so make sure you take good notes. So here's our first example. We have y equals 4x minus 7 and y equals negative 2x minus 1. Notice that both equations are in slope-intercept form. So if we wanted to, we could very easily graph both of these equations and find out where they meet. But we're going to look at algebraic methods here as well. And I want you to notice that both of these equations represent what y equals. In one case, we have y equals 4x minus 7. And here we have y equals negative 2x minus 1. Well, clearly we have both equations that say y equals. So the substitution method says, in this second equation, I can replace y with what y is equal to in the first equation, which is 4x minus 7. So really, I'm going to have an equation here with an equal sign and 2 sides, and we're going to say 4x minus 7 equals negative 2x minus 1. And the reason we can do that is because both sides are equal to y. Y is equal to 4x minus 7. Y is also equal to negative 2x minus 1. Therefore, both of these expressions must be equal to each other. Okay? Once we have that, this is a fairly easy equation for us to solve. We need to move everything that has an x on one side, everything that's not an x to the other side. I'll start off by adding 7 to both sides. So I have 4x equals negative 2x plus 6. I'll add 2x to both sides, running in a space here. 2x, fix that. 2x. I see that 6x equals 6, therefore x equals 1. 1. Can't get on the screen here. Equals 1. There it goes. So we find out that x equals 1. So if we have x equals 1, now we want to figure out what y equals. X equals 1. Well, the way I'm going to figure out what y equals is by plugging x equals 1 into either of the 2 equations. And you can pick either one. You'll get the same answer. I'm going to choose to plug it into this one. 4 times 1 minus 7, that equals y. 4 minus 7, that equals y. Therefore, y equals negative 3. So we find the place where these 2 lines intersect would be the point 1, negative 3. Okay? Hope you wrote your work a little bit clearer than I did here on my screen, where I was kind of all over the place. But that's okay. Here's a second example. In this second example, notice I have 2 equations in 2 different forms. I have one here that's in slope-intercept form, and I have one here that's in standard form. So what should I do here? Now again, if I wanted to graph, I could take the second equation and write it in slope-intercept form and graph both equations. I think if you started to do that, you would find out that we get some nasty fractions, and perhaps our graphing skills aren't so great. So here's what I'm going to do instead. I notice here that y equals to 2x plus 2. The substitution method says that, well, I have a y here in the second equation. I know that y equals 2x plus 2. So I'm going to rewrite the second equation, and when I encounter a y, I'm going to replace it, substitute it with 2x plus 2. So I have negative 4x plus 5 times, now I'm going to write 2x plus 2, parentheses are important, equals 18. So take a look at this second equation again. I rewrote it symbol for symbol from this equation here, but when I got to a y, I replaced it with 2x plus 2. And that's nice now because I have an equation that just has x's in it. I'm going to use my algebra skills here. 4x plus 10x plus 10 equals 18. Simplify a little bit. I'm going to subtract the 10 over here. I'm also going to combine like terms. So I have 6x equals 8. So therefore, if x equals 4/3, 8 divided by 6, x equals 4/3. So that looks a little intimidating, x equals 4/3, but it's not so bad. I just need to plug it in for x. Now it's easiest to take x equals 4/3 and plug it into this first equation here. So you see that y equals 2 times 4/3 plus 2. I have y equals 8/3 plus 2. I'm going to use the least common denominator here to add the fractions. Y equals 8/3 plus 6/3. And I find out that y equals 14/3. A little bit crazy of an answer because we have some nasty fractions, but these 2 lines will intersect at 4/3 and 14/3. Can't be scared off by fractions. They happen to us every now and then. Here's our third example. In this third example, I have two equations that are both written in standard form, and neither equation says x equals or y equals, so I can't immediately substitute. What I do see here in this first equation is I have an x. It'd be very nice if I was able to get that x all alone, and I would have x equals something, and I could substitute that. Well, the way I'm going to deal with that is I have x plus 2y equals negative 2. I'm going to move the 2y to the other side by subtracting it. So I have x equals negative 2y minus 2. And now I have an expression which x equals. Well, that's very nice because I can now take this and plug it into the second equation for x. I'll do that up here. I have 2 times negative 2y minus 2 minus 3y equals 17. Oops. Equals 17. I'm running out of space here on my screen. Do a little distributive property. I have negative 4y minus 4 minus 3y equals 17. Combine like terms. Negative 7y minus 4 equals 17. Add 4 to both sides. Negative 7y equals 21. Made in the shade. Now I divide by negative 7. I find out that y equals negative 3. All very good. Now I have to find out what x is equal to, and I have a couple choices here. I could plug y equals negative 3 into the first equation, into the second original equation, or I could even plug it into this one, and that's what I'm going to do. Keep in mind that x equals negative 2y minus 2, and I know that y equals negative 3. I can now plug it in. X equals negative 2 times negative 3 minus 2. I have x equals 6 minus 2. X equals 4. So therefore, the point of intersection is at 4, negative 3. So there are 3 examples with substitution. Hope you had a chance to absorb it. We'll have some practice problems in class tomorrow.